dear students. My name is Chamba.
And myself, Sarika Pundir, and I am here to present a topic on the periodic table, which is a topic of chemistry. And I would like to request Shambi to please start the topic.
So, as the topic is periodic table, let me give you an example. Example of our school timetable. As you know how our school timetable is properly arranged with proper time management. Similarly, there were many elements to be arranged and they were arranged in periodic table. Now, he is Dmitri Mendeleev and he was the one who classified the elements according to their atomic mass. Now Mendeleev, he states that the physical and chemical properties of elements are the periodic functions of their atomic mass, and he arranged 63 elements. Although there were many before scientists who discovered many laws, but they were discarded. And one of the main merit of Mendeleev was that he arranged the elements as groups and periods, and also he discovered gaps for the undiscovered elements. And there were some demerits also, and which led to the discardment of his table. Now next is Henry Moseley, and he states that the physical and chemical properties of elements are the periodic functions of their atomic number. Now he classified the elements according to the atomic number, and he clarified all the doubts that were occurring in the Mendeleev's periodic table. Now Niels Bohr and Henry Moseley, they gave the extended form of periodic table, which we studied today. Now this is a common thing as we are studying about the periodic table, so we should know what is periodic table. So tabular arrangement of elements in vertical columns known as groups and horizontal rows known as periods, and that is which shows the variations, that is known as your periodic table. And this is how we read the periodic table, as name of the carbon, then with its symbol and its atomic mass and atomic number. Now moving on to the salient features, first is periods. So periods are the horizontal rows. And what do they have common among themselves? They have common among themselves, that is the number of shells. Let's take the example of calcium. It has 4 shells. As it has 4 shells, so it is always used in the period 4. Now here similarly the examples of hydrogen and helium given. Moving on to the next slide. Now that is groups. What are known as groups? Next slide please. Now groups are known as vertical columns. Now as your periods, they have the number of shells common in themselves. Similarly, in groups we have valence electrons. Again, taking the example of magnesium, it has 2 valence electrons in the outermost shell. So of course it will be used in the group 1. Now here are representative elements. Group 1, 2 and from 13 to 17 they are known as representative elements. So group 1 is known as alkali metals, 1 valence electron in the outermost shell, and they are very reactive. Why they are very reactive? Because the tendency to lose the electrons is very high. Now the elements such as lithium, sodium, potassium, rubidium, cesium and francium falls under the group 1 alkali metals. Now group 2 is alkaline earth metals, and why they are known as alkaline earth metals? Because they react with the water to form alkalis but less reactive as compared to the alkali metals. Now they have 2 valence electrons in the outermost shell, and several of these elements are important such as calcium, which is present in milk. Now the elements such as beryllium, magnesium, calcium, strontium, barium and radium, they fall under the group 2, that is alkaline earth metals. Next slide please. Now group 3 to 12 are known as transition metals. Some of the characteristics of transition metals can be highly reactive by the magnates and high melting and boiling point and etc. Now here is some characteristics that you should know, that the lanthanide and actinide series, these 2 rows which are shown at the bottom, they are always written at the bottom of the table, and that's the reason is because if they will be used in the table, it will distort its shape. Now I request Sarika to please express our further topic.
So now I will start with what elements are present in the lanthanide and actinide series. So in the lanthanide series, there are the shiny elements and they are the naturally occurring elements. So, and in the actinide series, there are the heavy metals that are like, you might have heard the element uranium, and those are the examples that are present in the actinide series. Now next slide please. we come to the carbon family. Carbon family is the group number 13, the first element being carbon, and the number of electrons in the valence shell is equals to 3. Now carbon family, that is group number 14, 4 electrons in its outermost shell and carbon being the first element. Next slide please. Nitrogen family. So nitrogen family is the group number 15. It has 5 electrons in its outermost shell and the first element being nitrogen. Next comes group number 16, which is the oxygen family. 6 electrons in its outermost shell, and they are also known as the group of chalcogens because they are the ore forming elements are present in that group. Now group number 17. Group number 17 is the halogens group, which have 7 electrons in its outermost shell, and they are the highly reactive metals. Now group number 18, which is the group of noble gases. They are very unreactive, very obviously, because they are already stable in nature because of the octet or duplet rule. Octet in case of the other elements and duplet in the case of helium. Next slide please. Periodicity. So periodicity, so let's just forget chemistry, but if we take periodicity just as a word, so what is its meaning? It is like the reoccurrence or reappearance of elements, reappearance of the periodic properties at regular intervals with some gradations in it. And we cannot call it changes because it does not completely change the periodic properties. They just increase or decrease. And the main cause of periodicity is the repetition of the same number of electrons in the outermost shell. Now the key to periodicity. So she has already explained you what the key to periodicity, like what is the basis for the formation of the periodic table. So it is very obviously the atomic number. Now the atomic number. So atomic number, like we can conclude that atomic number is equals to the number of neutrons or equals to the number of protons or equals to the number of electrons. Now atomic mass. So atomic mass is like the atomic weight of an atom. So it is the sum of the number of protons and the number of neutrons. The valence electrons. So the valence electrons, by the name itself you can define it that valence electrons, like suppose there is an atom, so there is the outermost shell is there and the electrons that are present in that outermost shell are known as the valence electrons, and these elements are the electrons that are responsible for the sharing of the elements to electrons to the other atom, and they take active part in sharing. Now the periodic table. So see, here you can see a clear picture of the long form of the periodic table that we study today. You can see the significant role that is played by the atomic number here. You can see hydrogen, atomic number 1, beryllium 2, and so on. It continues like this. You can see the number, you can see the rows, you can see the columns, groups and periods. And the upper ones, the 1, 2, 13, 14, 15, 16, 17, 18 are the belonging to the A group, and the bottom ones are belonging to the B group. And you can see the last 2 rows that are the lanthanide and actinide series. So thank you for your kind attention. If you have any queries, please raise your hands.
Hydrogen is at the top of the periodic table. Why is it not counted in alkaline metals?
Please say loud.
Even though hydrogen is at the top of the periodic table, why is it not counted in alkaline metals?
Because it is, first of all, it has So, due to its dear nature, it is not even counted in their carrying metals. Any more questions? Thank you and sorry for the inconvenience of the science because of some issues. Thank you so much.